started from where it's at, continue until it hits the next breakpoint. So I'm just going to hit continue, and you see that it stops when it hits this next breakpoint. It didn't stop for any of these other stuff. I didn't have to step over individual lines. I can look at the piece that I'm looking at. I can set a breakpoint. I can say, oh, I'm done with that. I'm going to set this breakpoint and look at this piece over here, and I can just hit continue, and it'll run back to the breakpoint. I'm going to show you something real quick. When I want to clear a breakpoint, you just click it again, and it's gone. Okay? So here I am inside of this breakpoint, and this thing is a loop, and it's summing over this matrix, and it's also setting this matrix to be -1, all the values in the matrix to be -1. So let's pretend that for some reason, don't trust this loop. I think it's doing something bad. I'm going to clear this breakpoint. I think that this loop is doing something bad, but it's going to execute 200 times. But I think it's doing something bad at the, I is equal to 9 and j is equal to 17. I don't want to sit here and loop through this particular loop, these loops, 200 times by hand using step over. That's going to be very, very slow. So another thing that I can do with breakpoints is that I can right click. I just right clicked on the breakpoint. This little context menu comes up, right? You see this where it says condition? I can click condition, and what this is I can set a condition for when this breakpoint is hit. So it won't execute every time. It won't stop every time. It'll only stop when this condition is true, or optionally has changed if you choose has changed. But generally, you just want to use this true. So I'm going to say I want to stop when I equals. Let's see. When I is equal to 9 and j is equal to 18. Okay? So you use the exact same syntax that you use in C for this. Like this, the same syntax that you use in C++. You set the you can set your conditions. Your conditions can be anything. It can be arbitrary as long as the variables that you're using are in scope of the program. You have to make sure that that's true. They have to be in scope. Otherwise, of course, it's not going to make any sense. So I click that. Now you see the little plus show up, right? The plus means that there is a condition on that breakpoint. And I can highlight it, and I can see what that condition is. Now I'm just going to hit continue again because I'm not going to step through this line by line. I'm just going to hit continue. And I hit continue, and instantly this thing breaks. So the question that you always have is, well, did this thing actually break or did it not actually break in the right place? And if you look down here in your locals, you can see that I is 9 and j is 18. So it executed this loop however many times it executed, and it stopped when I is equal to 9 and j is equal to 18. Alright? So now that we're stopped here, we're going to look a little bit more at this particular. We're going to look a little bit more at something else that you can do. One thing that you sometimes want to do is you have a variable, say you're looking at a particular array element and you're curious what that array element is. Like, I'm really interested in what matrix ij is. I don't really want to go and click through the menu and try to figure out where that is in the if I want to do this via the locals, I could go to matrix. Well, you actually can't. I'll show you this in a second. Sorry. So if we want to see what this value is, we can just grab it, highlight it, what we're interested in, grab it, and drop it in here. And we see that the value of matrix is 0. We can also see that by just highlighting it. If we highlight the whole thing, now it has to be the whole thing. If you look, see the little tooltip that says 0, and I can even put a sticky here where it'll show up all the time if I want that to happen, or maybe I don't want that to happen. But in any case, I can drag this variable into the watch window, and I can see the value of this change. And so then I can step through this application. See me just using step over here, and you can see in fact that the value hasn't changed, but the I and j have. I is 9, j is 19. In this case, I can also tell by looking at the locals, watches. Alright, so let's say, for example, you also want to see what this matrix is. Let's look at this matrix in local. This is something that just came up, and I should explain this. So when I look at this matrix in local, inside of this function, alright, in the original case, when we were looking at it in main, we saw, when I was originally looking at it in main, we saw that it showed a nice little 10 by 20 matrix. We could view the row and column correctly, but now for some reason we can't. So the question is, why is that the case? It only shows like 19 elements of this thing. So why is that the case? Well, the reason is that, you remember when we passed this into this function, I don't pass the first array dimension, I only pass the second one. So as far as this function is concerned, this thing only has, it's got 20 columns long, and it doesn't know anything about the other dimension. It only knows about one of the dimensions. So when we go to view, we can't see things as nicely as we'd like to. So one solution for this is to go into the watch. We can highlight this variable, we can drag it here, and now we see matrix, but we see exactly the same thing. So one of the nice things about the watch window is that we can control exactly how we view the data. So in this case, I can add this comma 10, and what this tells the debugger is that the other dimension is 10 for this matrix. So now, when we click on this and you see the type, let me show you the type. It still says 20 star, but it's still going to interpret it as 10. When we look at the matrix, you see now we have this nice row of 9, and we can click down and we have this row of 20 elements inside of it. So the matrix is displaying the same way now that it was inside of the original main where we declared it, even though inside this function the program itself doesn't know what the other dimension is. We're telling the debugger what the other dimension is so that it can display it correctly for us. There's a wide variety of stuff that you can do with watches. I'm not going to cover all of them because I think it's probably too advanced, but there's a lot of things that you can do with watches that are very useful as far as displaying your data correctly. This is probably one of the most useful ones for displaying what is some dimension data. It's just comma 10 or comma whatever the dimension is. So we've stopped here, we've looked at this thing. One other thing that you can do inside of the debugger is you can actually change the value of the variable. So for example, I just changed this value to 1. And if I go and I do the tooltip highlight thing with this thing, you can see that in fact the value is 1. I've changed it. It's not something I would recommend you do. It's not something that's horribly useful to be able to do, but it's something you can do. Alright, let's talk about one more thing. I'm going to clear this breakpoint, and I'm going to set another breakpoint right down here. Actually, I'm not going to set a breakpoint. I'm going to do something else. Another thing that you can do, if you set the cursor at a certain particular point, like I've clicked here, so the cursor is now, see the little blinky cursor like I was going to type, it's set now here, it's set value. If I right click this, and I get this context menu that pops up, one of the things that I can do is click run to cursor. Okay? So, run to cursor, and you see it stops wherever my cursor was. So if you don't want to set breakpoints, you don't have a reason to set breakpoints, you just want to run a little bit farther down in your code, but you don't want to bother with setting breakpoints, you can just right click, run the cursor. It's really not a big deal. You can do it that way, or you can set breakpoints either way, whatever's more convenient for you. So now we're going to step inside this function, this set value function. And now we're inside the set value function. I'm going to show you one other fairly useful thing here. I'm going to resize this slightly. And that is, see this window listed as call stack? So you can see here, it looks a lot. There's some stuff in here that is not part of your application. That's stuff that Visual Studio adds, or that's part of Windows. But you see we have main, sum matrix, set value. What this is a list of the functions. So we've called sum matrix from inside of main, and we've called set value from inside of sum matrix. So this is called a call stack, and this is like the stack of programs. When we exit out of this, it's going to go down, it's going to go back into sum matrix, and the set value is going to disappear. But what I want to show you is, when you see this, you can double click on it, and you can see exactly where you are in your application, and you can see what line he's executing. Like if I'm here in set value, I'm stopped in set value, I want to see where this is called from. I can go, oh, it's called from sum matrix. I can look at the variables inside of sum matrix, or I can go back to main. I can look at the variables that are inside of main. Of course, inside of the set value class itself, I can't see any of those variables because they're not in scope inside of this function. They're only visible at the higher level. But I can use this call stack to go up and down the stack of called functions to see what was happening in main when this function was called, when this breakpoint was hit, what was happening in the next function that was called, what was happening in the next function. You can also see there's a drop down here for the stack frame that you can use to do the same thing. Thread, don't just ignore this thread, and process bar, you'll need that not in this course. But you know, being able to go up and down the call stack is pretty useful. So let's say I'm gonna go back to some matrix. I'm gonna set a breakpoint right here because this is what I want to stop at. And I don't actually have to go back to set value to continue this program. I can just say I'm going to continue this, and I can continue it. Now I'm stopped in sum matrix, the sum matrix function, okay? And I'm about to return this sum. If you look back at the call stack now only shows sum matrix and main. That's because I've exited from the other function. It's no longer on the call stack. It's not being executed. I'm executing sum matrix now. So now I'm going to use the ever useful step out of function to step out of this function, and I'm going to show you one more thing. So let's say you're sitting here and you accidentally step into this. So I did a step into here, and the next function that was about to be called was this insertion operator that we were talking about. And you can see that I'm in this insertion operator code. So your question is, what do I do in this case? I don't recognize this code. It's a bunch of garbage. Sometimes it can even be other types of garbage. How do I get out of this? What do I want to do? Well, the easiest thing to do is just to click step out of. If I click step out of, I'm going to execute the current function that I'm in. I'm going to step out of that function, and here I am back where I wanted to be in main. And this time I can wisely click step over, step over, step over, and here we are at the breakpoint.